Welcome to Hydrocarbons Part 3. In this video tutorial, we'll focus on IUPAC Nomenclature of Alkanes, Alkenes, Alkynes, and Benzenes. Let's get started. Alrighty, so IUPAC, if you're wondering what that stands for, it's an international organization that goes by International Union of Pure and Applied Chemistry. And this is the group of people that have made up and created the rules that we're going to learn today for naming hydrocarbons. So hydrocarbons is very literal. It means that the only elements present in the compound are carbon and hydrogen. Now, alkanes, this is where we have all carbon-carbon single bonds. Alkenes, we're going to have at least one carbon-carbon double bond. Alkynes will have at least one carbon-carbon triple bond. And then aromatic compounds or arenes, we will focus on benzene, which is a 6-carbon ring with alternating double and triple bonds. So when we describe alkanes, we have the maximum number of hydrogens. So we describe alkanes as being saturated hydrocarbons. In the same way that a saturated solution is holding the maximum amount of solute, the carbons are holding the maximum amount of hydrogens. And so when we look at the chemical formula of an alkane, right, we have CnH2n plus 2. With alkenes, alkynes, and aromatics, we have lost some of the hydrogens, right? With an alkene, it's CnH2n, and for alkynes, H2n minus 2. So we've lost hydrogens. So we describe those as unsaturated. And you'll hear these words in describing fats and the hydrocarbon tails of fats being saturated fats or unsaturated fats. So we will come back to these terms in the future, right? And the main thing is H's are lost, right, to create the double and triple bonds, right? Since carbon can only have 4 bonds, if it's creating double and triple bonds, it loses its bonds to hydrogen. Alrighty, so now we'll look at names. The names have 3 parts. The straight chains are named using the root names from the homologous series. The root name I'll also describe as the parent name. We can make alkanes into rings. When we make them into a ring, we're going to put cyclo in the front to indicate that we have formed a ring. And then the suffix of each name will tell us about the type of bonding. So when we have all carbon single bonds, it's an ane. When we have at least one double bond, an alkene. And if there's a triple bond, we will call it alkyne. So the suffix of each name tells us about the type of bonding that occurs in the molecule. Now we need to look much closer at the homologous series. So let's go to the next page. So in this next page, now the homologous series is much longer than what I've shown, but this is enough for our purposes. This is something that you need to memorize. So initially we'll be focusing on the suffix names, but once we get more complicated, we will see that the parent can have branches, and then we'll need to be aware of the substituent names. So notice the difference. When it's a suffix name, it ends in ane, or ene or ein. But when it's a branch, it ends in yl. All right. So when we have one carbon, it's methane, CH4. If we have a 2-carbon chain, it's ethane. CH3, CH3. Okay, now we're getting to longer carbon chains, so we can bring in our skeletal line structures, right? A 3-carbon chain, propane. 4 carbons, butane. 5 carbons, pent. 6 is hex. If you have any if you speak of Latin-based language, you'll recognize these names. Heptane is 7. There's our 7 carbons. Octane, from the good old octet rule. Everybody should recognize the oct for 8, non for 9, and dec for 10. So now this is if they're the parent or the root. If they're a branch, then they end in the YL. And for lack of a better place, we're going to focus on the IUPAC names. But there are some common, here's a common name or reference that I want you to be aware of because it tends to show up in biological applications. When we have one CH2 group, right, these many CH2 groups in the middle of a long chain, one of them is called a methylene group. 2, right, would be ethylene. And 3 would be propylene. And this pattern could continue, but generally you'll see it just in these small carbons. Sometimes these common names appear. And so if you see them, I don't want you to get thrown by them. But the main emphasis will be on our IUPAC names and the homologous series. So now let's look at naming the simplest compounds, something that's a straight chain with no branches. Alrighty, so the first thing we do is we're going to count the carbons, right? We're going to find the root or the parent by counting the carbons. So that's where the homologous series comes in. All right, and then we assign the suffix, and the suffix comes, right? There's all single bonds, ane. If we see a double bond, ene, and a triple bond, ine. All right. Now, if there is a double or a triple bond, we have to tell everybody where it's at. So we will put a locator number in to tell everybody where the double and the triple bond are. It's important to note that when we're numbering the chain, we want to give the double or the triple bond the lowest possible number. And then for cycloalkanes or alkenes, remember that it's possible to have a geometric isomer, and if we do, then we'll make sure to add that to the name. Alrighty, so let's start. I think it's easier to start with a name and draw a structure. So let's get warmed up. Notice what we're looking here and we see, oh, okay, there's an ene. That tells us there's a double bond, and we know that double bond is going to come off carbon 2. How big is our root? How big is our parent chain? That's right here with the hex. So hex is 6. So we'll draw a 6-carbon chain. Alrighty, so there's our 6-carbon chain. I'll just label it there so we're all together. And then we know that there is a double bond coming off of carbon 2. So we'll put that right here. So 2 atoms always share the double bond. We only say the lowest number. And then I lucked out here because it says trans. So trans would tell us that they're across the double bond. This type of trans can often be tricky to see. When we first learn it, it's very explicitly written for us across the double bond. But then when you see them in your text material, it's rotated into the plane of the paper. Alrighty, let's try another one. So this time we note, right, we have ine and 3. So we recognize we have a triple bond, and with the oct, there's our root, so we know we have an 8-carbon chain. And I'll pay attention, this time it says cis. So I'm going to start with the double bond. And I know the double bond is going to start at carbon 3, and this will be carbon 4. We need to end up with an 8-carbon chain. So carbon 2 and carbon 1. So 1, 2, 3, 4. Now cis, so we want to bring this down so they're on the same side. So that would be carbon 5, 6, 7, 8. Let me write those out so everybody sees it. There we go. All right. So now we have correctly drawn the structure for cis 3. Oh, I made a mistake. Octyne. So octyne would tell us it's a triple bond. So we'd put a triple bond here. So, and sometimes this is helpful to draw the angles. Technically this is linear. So, so then there shouldn't be any cis. Okay, so that was a bad question. We can't have cis if we have an alkyne. But that's all right. And let's just redraw it. 1, 2. There's our 1, 2, 3, 4, and then 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Most commonly with alkynes, you'll see it straight away because of this linear angle there. Okay, well, I think that one will be all right. Let's keep going. Here we see cyclo. That tells us we have a ring. And then ane, all carbon-carbon single bonds. And then the pent tells us that we would have 5 carbons. So this is a very simple one to draw. It's simply a pentagram. That would be cyclopentane. Alrighty, now for the more challenging part. Looking at the compound and giving the IUPAC name. So we'll get warmed up with a pretty simple one. We see a ring. As soon as we see a ring, make sure to write cyclo. And then we simply count the number of carbons. And so we have cyclohexane, all single bonds. Alrighty. Now for this next one, we have a double bond. So remember, we want to name it to give this the lowest possible number. So in this case, we're going to number left to right because that gives us a 2. And notice in this case, right there, it's across the double bond. So we would say trans 2 pentene. Remembering that the 2 is telling everybody where the double bond occurs. And then this last example, and we have 1, 2, 3, 4. So it's important to recognize, right, as we transition from a single bond to a triple bond, there has to be an atom there to make that connection. And so this would be 2-butyne, with the 2 telling everybody where to find the triple bond. Alrighty, so now that we have the basics down, let's look what happens when our parent chain has branches. So in this type of compound, we're going to look for the main chain. We'll call that the root or the parent. And that's the longest continuous carbon chain. All right? And then the substituents, these will be the branches. All right? So there we go. Okay. So remember that our main chain will be the parent or the root, and then the substituents. So with substituents, remember that this will be the YL, right? We'll use the YL to indicate that it's a substituent. Alrighty, so let's look here. Find the longest continuous carbon chain and assign the root name. So when we look at this molecule here, we can find 1, 2, 3, 4, 5, 6, 7. So there's our longest chain. All right, so that tells us that the root name will be heptane because it's all single bonds. So now, okay, so we've assigned the suffix. Then we want to look at the branches, but let's look at the numbering first. We could number this left to right, or we could number right to left. When you're first starting out, then you probably want to try to number it both ways, and then we'll figure out which numbers are correct. So let's find our branches, okay? Right, assigning a locator number to all substituents. Let's name them first. So there's a substituent, and a substituent. So 1 carbon is a methyl. 1 carbon is a methyl, and 2 carbons is an ethyl. All right, so we've named our substituents. Okay, now we have to assign the locator numbers. This is how we decide, should we be using the red numbers or the green numbers? And so, there are no double or triple bonds. If we did, this is the first priority. However, for this molecule, we don't have any double or triple bonds. So then what we do is we want the first branch to have the lowest possible number. So if we look at the red numbers, right, the first branch is on carbon 3. If we look at, I'll circle that so everyone can see it. If we look at the green numbers, notice that the first branch, right, is on carbon 2. All right, so the green numbers win. Okay, so now we will use the green numbers to assemble the name. When we have more than one methyl group, we will indicate that with a di, a tri, or a tetra. So since we have 2 methyl groups, we would call this dimethyl. Okay, so now let's put this all together. One last thing to point out is that the substituents, we give those in alphabetical order. And so even though it's dimethyl, we would use the M. So we don't consider the prefixes in the alphabetization. So E comes before M. Let's put this name together. All right, so the ethyl comes first, and the ethyl is coming off of carbon 4. So we say 4-ethyl. And then we have 2 methyl groups. So the methyl groups are coming off of carbon 2 and carbon 5. So 2, 5 dimethyl. And now we finally get to put heptane. So notice every atom in the molecule is accounted for, all aspects of the structure. Let's try one more together. Alrighty, so the first thing, right, find the longest continuous carbon chain, and then we have to decide how to number it. Remember, the double and triple bonds have the top priority, so we can look at this molecule and see the double bond is closer to the right. So we're going to want to go 1, 2, 3, 4, 5, 6, 7, 8. So we found our longest continuous carbon chain, and we see that there's a double bond coming off of carbon 3. So that would be 3-octene. Then we can look at our substituents. This time we have 3 methyl groups. All right, so that would be trimethyl. And we have to tell everybody where they are. So that would be 5, 6, 7. Notice that if we have 3 numbers here, we better have a tri, right? This always has to match. And then, whenever we have a cycloalkane or a alkene, remember that we have to think about cis or trans. In this case, we look at this double bond, and it's a trans double bond. So the full name for this compound is trans 5,6,7 trimethyl 3-octene. Remembering that the 3 is telling us where to find the double bond. Alrighty, so nomenclature can be very challenging, so I think it's important to work some more practice problems. Let's practice again this time, and we'll start with what I consider the easier of the two, working from the name. So if we look at this name, we see here's our root. We know we have a 6-carbon chain, and we see there's a double bond at carbon number 2. So, and we see that it's cis. All right, so there's going to be our, we'll put here and there. So 1, 2, 3, 4, 5, 6. So let me number that for everybody. Okay, so the root told us, hex told us 6 carbons. We know to put the double bond at carbon 2, and then the stereochemistry, we put the alkyl branches on the same side because of cis. And then the last piece here is we have a substituent. So we go to carbon 4, and we add an ethyl group, 2 carbons. So there we go. This is the structure for cis, 4-ethyl, 2-hexene. Let's try one more. Here we have cyclohexane. So we'll make a 6-membered ring. And then we notice here it says trans. So we'll have 1 wedge and 1 dash to show that the substituents are above and below the ring. So we'll just randomly put 1, 2, 3, 4, 5, 6. We can put them any order they want. Okay, 1-ethyl. So I'll make that a wedge. Right, and then CH2, CH3. And then coming off of carbon 3, we'll make sure that that's a dash. CH3 to give our trans. So there we go. Now, a little bit more challenging, given the structure, what is the name? So when we look here, this one, we can go 1, 2, 3, 4, 5, 6, 7, 8. This numbering, notice both directions give us a 3, but numbering this way we get a 3, 4 as opposed to a 3, 5. So we'll go with that numbering. And then we identify all of our substituents. So this would be 3, 4, 5 trimethyl octane. Alrighty, let's move on to the next one. So now we have a double bond. And we can look and see that all of the branches are coming off of the same side. So we know that this compound will be a cis. Alrighty, let's figure out, so the numbering, we want to give the double bond the lowest possible number, so we know to start numbering on the left, and then we keep going to find the longest carbon chain. So now we look at 7, so we recognize that's going to be hept, and we have the double bond, so that will be heptene, and the double bond starts at carbon 2. But before we get there, we need to look at the substituents. Remember that the substituents are cited alphabetically. So this ethyl group will be cited before the methyl group. So cis for ethyl, 5-methyl, and then we can bring in our parent or our root, 2-heptene, right? And the 2 is telling everybody where to find the double bond. All right, one last one here. So we can number, it's in the middle, the triple bond's in the middle, so we can number from the left or the right. We'll get the same result. And we have our 2-methyl substituents. So it would be 2,5-dimethyl, and with octine, or with hexine, with alkynes, we don't have to worry about cis or trans. And then we tell everybody, right, 3-hexine. So there's the 3 telling everybody where to find the triple bond. Alrighty, so that covers alkanes, alkenes, and alkynes. They have a very similar naming strategy that we've practiced together. Let's briefly look at aromatics, benzene rings. This is not a huge emphasis in the course, but it's good to cover it because there's a couple important benzene derivatives. So, oh, whoops, those are my notes. Here. Got a sneak preview of what's going to happen on this page. Alrighty. So, root names. So, in my class, you're responsible for benzene. Remembering that the alternating double bonds can be shown, or you can write a circle in the middle, right? I also want you to remember this compound. There's the CH3 group. That's toluene. And when we put an alcohol group on there, we call that a phenol. All right? So these are the 3 root names that you want to know. Substituents, we'll just focus on the alkyl substituents. So those will all come from the homologous series. Okay, so if there's more than one substituent present, then we give the second substituent the lowest possible number. The first substituent always is given the number 1. So for toluene or phenol, the number 1 carbon would be the carbon on the ring that's bonded to the methyl group or the alcohol group. And then we're going to follow the same procedure as before, listing the substituents in alphabetical order. And of course, always providing a locator number so that people know where they're at. If we have a lot of substituents, we can use the prefixes that we learned in naming alkanes, alkenes, and alkynes, right? So then just to emphasize, right, make sure that you recognize toluene and phenol. Phenol is very important. It was one of the original antiseptics when human beings acknowledged germ theory. Okay, so, and remember that aromatic rings are the one ring that we are able to write in a condensed formula. So we'll get to that in this next example, right? So draw the skeletal line structure for 3-propyl phenol. right? So the phenol tells us this. And then we have our double bonds. So that becomes carbon 1, carbon 2, 3, 4, 5, 6. So then the second part of the name says that coming off of carbon 3, we have propyl, which you recognize as a 3-carbon chain. So 1, 2, 3. Okay, so this would be the structure of 3-propyl phenol. And then our last example, C6H5. We want to recognize that as the benzene ring. This is the C6H5. All right, and then this will be the branch or the substituent. And since there's only one branch, we don't worry about, it can go anywhere. So 1, 2, 3, 4. And so that would be, so now that we have the structure, let's give the IUPAC name. So this would be butyl benzene. So the benzene ring is here, and then there's the branch coming off. Alrighty, so we've worked through quite a bit of nomenclature practice, and this would be a great time to dig into your homework and work a few practice problems to reinforce your understanding.